The ways of our universe are as complicated and intricate as one could imagine, for it is all of what we know. However, in our understanding underlies three basic rules, Newton's laws. These laws are the foundation of what everything functions under in our universe. But exactly how each law functions is what we will be digging into today. To understand the universe, you must first understand its laws. To begin, we must first understand Newton's first law, best known as the law of inertia. Newton's first law describes that an object at rest or in motion will remain doing whatever it is doing until an outwards force acts upon it. As you can see here, this is a meteor barreling through space. Since no forces have acted upon it, the meteor remains in the motion and direction it was set at, until the meteor acts upon another physical object, like a spaceship or another meteor. It will remain at the speed it is at and the direction it is heading in indefinitely. Now, not all objects are in space, however. Let's take a much more real example down here on Earth. Now here we have our assistant Pfeffram to show us Newton's first law in a much more down-to-earth method. As you can see, he is standing still right now without any outwards force being applied. However, now outwards force is applied to Pfeffram. We can see him move with the force along its path. Now, there are many more variables that apply here. Friction slows down any force if constant energy on the object is not being kept for it to move. And gravity will make Pfeffram's path take a downwards arc, leaving him on the ground. Now, while certain variables on Earth change factors of Newton's first law, there still must always be the initial force applied for an object to change their current status of motion, as seen here. Now, we move on to Newton's second law of motion, which is described by a simple equation. Force is equal to mass times acceleration. Let's go on ahead and put this function into practice to better understand it. Take this car, for example. Taking averages of a car of its type, a muscle car, I'd say it has a mass of about 1,600 kilograms, an acceleration of 12 meters per second. From those two data points, we can multiply them together and find that this car has a force of about 19,200 newtons. If the car had parts taken off, or it was driving at a slower acceleration, it would have a lower force in newtons. Now, to better explain the difference, let's take these blue plastic barrels here and connect some together. We'll start with 4 barrels connected together, and we'll put these rockets on them that exert around 200 newtons worth of force. Now, as you can see, they go quite fast, indicating they have a high acceleration. If you double the number of barrels, as you can see, they move much slower with the same rocket force. Quadruple the 4 barrels, and they barely move at all. This is due to the second law's equation. Much as mass times acceleration equals the force of an object, its force divided by its acceleration, or in this case, its force divided by its mass, will equal the final unknown value. Now, we finally get to the last law, Newton's third law of motion, most well known by the phrase, "For every action, there must be an equal and opposite reaction." Within every interaction, we can see this law time and time again. Here we see an example of Newton's third law. Though to first understand this complex function, we must understand the workings of everything around the car. As the car comes driving by, the constant force of gravity is pushing down against it, but there is a force applied back towards the car called normal force that keeps it from bellowing below the earth. There is force applied from the wheels that causes friction between the ground and the wheels. This, in turn, allows the car to move forward. And the final entente, the car and the wall themselves. The car moves into the wall, causing a minor dent in the wall, but no real pushback to move the wall anywhere. However, the force applied to the car causes major damage, shooting it back and most likely damaging the driver within. Please note that we could not afford the physics to replicate the damage, but the idea is still here. Now, this effect, with Newton's third law, is tied to everything. Not just car crashes, but the effects of Newton's third law itself is what causes the world to go round. Walking against the ground is forcing you against it, propelling your body forward. Same thing with rocket propulsion, with the rocket applying a backwards force, moving the rocket forward in the opposite direction of the force. And even in this scenario of a man throwing a can at this cop's head, we see the can have force on the head, pushing into the opposite direction of where it dented. The cop runs over, pushing his feet against the floor to walk forwards. And finally, he utilizes his sun stick to apply force of justice to the man's head, which both the stun stick and head react to, leaving the man on the ground unconscious. Just beautiful the way physics works. Every force in the universe works under these three laws, and with your new understanding, you can rule physics with an iron fist. Well, a very basic understanding, so more like regular fists, and with less of the rule part, more of a basic entry bureaucratic position, but still practically the same thing. So go out there and remember what Newton taught you.